Hey, what's up guys? Today, I'm going to be showing you what radicals are. Now, if you had not took math in more than 5 years, or you procrastinated on that radical test for so long it's 12 a.m. right now, and you're at your bed scrambling for YouTube videos to find out how to figure out what square root of 2 times square root of 3 is, well, don't worry, this is the perfect video for you. But this is only for radicals. I mean, like, what do you expect this? It's teaching you radicals. We were gonna teach you calculus here. Now, what are radicals? You may ask. Well, a radical is a quantity forming or expressing the root of another. Or basically simple math terms. You see those signs that are above the root numbers? Though that's basically what a radical is. It's pretty rad if you ask me. Now you may be asking again, where did these radicals come from? Well, they came from this guy who is an Arab mathematician called Abu al-Hasan ibn Ali al-Qalasadi contender for second longest name. First is Hubert Blaine Wolfenschlag and Stein, who has sang Burgundorf Senior. Man really had to get a double line on his Google Docs for his name. Some people may say that it comes from the letter Jim, or Jim, which is the first letter of Jadir, meaning root. However, other lively sources say that this one guy called Leonard Euler says that it originated from the Latin word radix, or what also means root. The first uses was used without the vinculum, or the straight top line next to the radical sign. Then, in 1637, this beautiful boy named Descartes was the first to combine the German radical sign and the vinculum to make up the radical sign we use today. Now, we usually go with the usual radical sign with a number on the inside. We use that to find the square root of a number, like square root of 36, which is 6 by the way. But you can go a step further and give that root an exponent. More worries for your algebra exam that you forgot to study for. But it's fine, I'm here to help. So let's say you use number 3 as exponent. Instead of finding the square root of it, you would have to find the cube root of it, or the third root of it. Same would apply if you would add 4 and 5, 6, 7, 8, 9, 10, etc. Almost every number. So now how do we solve these two type of roots? Well, the simple answer would be factoring. Basically, we factor out the number under the radical until we cannot factor anymore. Let's take the cube root of 27. First, we can factor out 3, because 3 is a factor of 27, and 3 times 9 equals 27, so we're left with 9 times 3 under the radical sign. So, we can factor out 3 again by using 9, so we can get 3 times 3 times 3 under the radical. So then, we can take those 3, combine them together, and give us 3 without a radical root sign. So basically, we would just put 3. Now, this also applies for other numbers. Let's put 4 now, for our exponent. So, let's do 4 root of 16. So we would just factor it, just go boom bam ba, to give you this. So now we know how to simplify. Can we add these radicals? You may ask. I don't know why would you ask that, but heck yeah we can. So let's take the equation 4 cube root of 5 plus 7 cube root of 5. So let's check the rules of adding before we add them. One is that if they have the same number under the radical and index, so if they would have a 5 under the radical and a 7 under the radical and you're trying to add them, I'm calling the cops on you. You're going to jail. That's a federal crime. But if there's a 5, there's a radical with a 5 in it, and then another radical with a 5 under it, you're free to go. So let's use the equation 4 cube root of 5 plus 7 cube root of 5. So we would get, or no, we wouldn't get it. We have to check it first. I'm a dumb idiot. I'm the dumbest man ever. So we would first check to see if they have the same number. And lucky we guess. Look at that. They both have the same number under the radical. They both have, so we can add them together. But wait a minute, there's another rule. They have the same indexes. Now, you may be asking, what indexes? What are you talking about? What are you talking about? Go take your medications. Well, lucky for you, I already did. And basically, what indexes are the exponents of the radicals. Basically, yeah, you could just call it exponents, it doesn't matter. So, they both are cube root, which is 3, so you can add them now. So, 4 plus 7 is 11, and then you can just do 11 cube root of 5. Simple. This also works for subtraction too, so let's just take the same equation, just replace the plus with a minus. So 4 cube root of 5 and 7 cube root of 5. Check the indexes, same, check the radical, the number under the radical, they're the same, subtract them both, that gives you negative 3 cube root of 5. So yeah, now, again, to that one crazy person in the back of the classroom who was like, hey, can we multiply it? And I'm like, heck flippin' yeah, you can. Just you gotta take those expressions, you gotta take those equations, man. Gotta take them, gotta multiply them across. So let's get the equation root of 2 times root of 5. So with multiplication, you don't really need to worry about the number under the radical. So if we multiply root of 2 times root of 5, that would give us root of 10. The real major problem comes when we have different indexes. So let's say root of 2 times cube root of 3. So what we would do there is change the radicals into an exponent. So how we could do that is by saying like, oh well, we could take the numerator of the 1. We can take the numerator of the 2 inside the radical, which is 1. And we can take the index of the radical, which is 2. A little side note: if you see a radical without a number, that the index is always 2. So we would get 2 to the power of 1/2, and we would do the same for cube root of 3, which is 2 to the power of 1/3. So we get 2 to the power of 1/2 times 2 to the power of 1/3. Now we add both of those exponents together, which they both go on a lovely date and make a exponent called 5, 6. So we get 2 5, 6 as our answer. And yeah, that's how we multiply with different indexes. Now some of you may be asking, why? 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 Why would we need to know this? Why do I need to know this? Now, first off, you clicked on this video, and it literally says radical simplifying, so kinda your fault. No, but actually, some real world applications are financing industry. So it can be used for finding formulas for interest, home inflation, and interest as well.
What's wrong, Matthew?
Nothing. I just forgot the formula to finding the interest of our stocks, and any number I use don't work out so well.
Bro, just use some radicals.
You know what? I'll try that. Wow, it actually worked. Thank you, Joey.
No problem.
Also, electrical engineers use them too for calculations, measurements, and yeah.
When these calculations sure are hard, luckily these radicals are making them easy to finish. Where is my one?
And also you, yes you, the fan, the man, the one, the man, the woman watching this video, who's using this for their next big algebra test that you forgot to study, and now you're watching this video frantically, waiting until It explains what you need. Well, yeah, that's basically what radicals are, right? How you add, subtract, and multiply them.